Let's do an example where we identify some transformations of a toolkit function and then sketch the resulting transformations. So I have two functions here. I have 1/2 parentheses negative x cubed as g of x, and I have h of x, which is negative absolute value of 2x. And we'll go ahead and start with problem A. Now these types of problems, they have a few more steps than the previous types of examples that we've done. The first thing that I'm going to ask is, which toolkit function? So what toolkit function is relevant for g of x? Well, I have a cube here, so the relevant toolkit function will be the x cubed function. So the answer is f of x equals x cubed. The next thing that I'm going to do is I'm going to write what g of x is in terms of f. And what I mean by that is on the right-hand side, I want something involving f of x. It is much easier to identify what transformations are taking place if you can write g of x in terms of f of x. Your skills in function composition will come in quite handy in this step. So I look and I see on the right-hand side that I have this 1/2 and it's multiplying something cubed. F of x is the operation that cubes. So if 1/2 is multiplying something cubed, then I'm going to have f here. Now, f of what? Whatever you put in this parentheses, it has to be the thing that's being cubed. And in part A, what's being cubed? Negative x. After you write g in terms of f, then we can go ahead and identify what transformations are taking place. So I have a 1/2 multiplying on the outside. That's going to give me a vertical compression. And I have a negative on the inside, and that will give me a horizontal reflection. So I have vertical compression by a factor of 1/2. Remember, that means we're multiplying all of the y values by 1/2. And then I have a horizontal reflection and if I'm moving horizontally, that means I have to cross the y-axis, so about the y-axis. Now I know what transformations are being applied to my toolkit function, and I'm going to go ahead and sketch my toolkit function. So we'll sketch and transform. Let's go ahead and get a good sketch. Get your axes. I probably will only be able to plot to the x value of 2 because the toolkit function x cubed gets quite large. 3 cubed is 27. So I won't be able to sketch too many x values, but I think I can fit the first couple. 2 cubed is 8, so I know I at least need the y value of 8. So 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. And one thing you can do, and I think I'll do this here, is you don't have to use the same scaling for your x and y axis. So I think I'll change my scaling so that I can fit more on here. So it looks a little strange, but it's an acceptable thing to do, especially with functions that get quite large, like x cubed. So my original function, my toolkit function, x cubed, has points at 1, 1, and then 2, 8, because 2 cubed is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Negative 1 cubed is negative 1, and negative 2 cubed is negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. So here is a sketch. And of course, 0, 0 is also on the graph of x cubed. Here's a sketch of the toolkit function. Now to graph my transformed function, I need to apply the transformations that I listed, which is a vertical compression by 1/2, and then a horizontal reflection about the y-axis. That reminds me I should probably label my axes. Now let's go ahead and start with the point 2, 8 and apply our transformations. We need to do a vertical compression by a factor of 1/2, which means we take the y value of 8, multiply it by 1/2, and we get to the y value of 4. Then we need to do a horizontal reflection about the y-axis. To do that, we'll take our x value of 2, multiply it by -1, and get -2. So we end up at the point 2, 4, or excuse me, -2, 4. I think I'll go ahead and make this yellow. And now let's go to the point 1, 1. We multiply the y value by 1/2. That would get us to a y value of 1/2. Then we reflect about the y-axis. To do that, multiply the x value by -1, and we get to -1, 1/2. 0, 0 will stay in the same spot. That's because if you multiply anything by 0, you get 0. Now let's go to the point -1, -1. We multiply the y value by 1/2. We get to -1/2 as a y value. Then we multiply the x value of -1 by -1, and we get to +1 to do our reflection about the y-axis. And then finally, at -2, -8, we multiply by 1/2 the y value. So -8 times 1/2, that'll be -4. And then we reflect, and we get to +2. After you've transformed the points, we'll go ahead and connect with a curve that resembles the original curve. That one didn't look the best. Let's see if we can do a little bit better. And perfect. Let's recap before we go to the next function, or perhaps more accurately, the next problem, part B. So we identified which toolkit, that is, what is the toolkit function that's relevant. We wrote G in terms of F. We identified the transformations. Then we sketched our toolkit function and transformed it. Let's move on to part B, negative absolute value of 2x. Let's go ahead first and figure out the relevant toolkit function. Well, I have an absolute value in here, so the relevant toolkit function is going to be f of x equals absolute value of x. Now I'll go ahead and rewrite this in terms of f. I think this was originally called h of x, so I'll call it h of x here. So h of x is equal to, now notice this negative is outside of my toolkit function. So I'm going to apply that negative outside. And now absolute value, that's what f does. So I'll write f. And whatever is inside the absolute value is what I'm going to put in the parentheses here. So 2x. From here, we can identify our transformations. So we have this negative on the outside. That's going to indicate a vertical reflection. And vertical reflections happen about the x-axis. And on the inside, I'm multiplying by 2. So it's going to be a horizontal transformation because it's happening on the inside of the parentheses. It is either going to be a horizontal stretch or compression, and we can identify which one it is by identifying what B is, 2. And remember, the horizontal transformations, they are counterintuitive. Instead of being a stretch, it is going to be a compression. So horizontal compression by 1 over B, and B is 2, so this is going to be by 1/2. After this, we sketch and transform. So we'll sketch our toolkit function absolute value of x. We'll do a vertical reflection by multiplying all of the y values by -1. Then we'll do a horizontal compression by multiplying all the x values by 1/2. I have my toolkit function sketched here, and I'm going to go ahead and apply these transformations. So I'll start at the point 3, 3. We'll do a vertical reflection that will change the y value to -3, and then we will do a horizontal compression by 1/2. We'll multiply our x value of 3 by 1/2. That will get us 3/2 as the x value, which is 1.5, which ends us up at 1.5, -3. Let's go to 2, 2. Do this a little bit faster. So reflect, then vertical compression, 1, 1, reflect, vertical compression, and I'll go ahead and fill in the rest here very quickly. And we'll go ahead and connect these with something that resembles the original toolkit function.